Howdy, this is Dr. Chapar. We are covering inventory strategy, and today's topic is the periodic review inventory system. In a periodic review inventory system, the inventories are reviewed periodically. This periodic review could be done every day, once a week, twice a week, or any other frequency. Idea is that you determine an order up to level and review your inventories at those predetermined time frames. For example, let's say we review our inventory at this point. Given the inventory position at this point, we decide what should be the order quantity, in this case quantity 1 or Q1. Then we place the order and wait until we receive the shipment. Right? At the end of the lead time, we receive the shipment, and then our inventory position and inventory level kind of catches up. We keep selling. At the end of the review interval, we review the inventories again. This time, let's say our inventory position is here, so we are gonna place an order of Q2, and that is the size of it. Then wait until we receive the shipment and go through this process. So in order to operate an periodic review inventory system, we need to determine T and order up to level M. Now you could choose any T and any M, of course, but we are trying to find the optimum T review interval and optimum order up to level, right, to minimize our total cost. Calculating T, you can calculate the T using the relationship between Q and D. T and Q, basically T, the review interval, is equal to Q over D. What it means is that, let's say over a year, my total demand is 1200, and every time I place an order of size 100. So you can see that in a 1 year time period, I'm gonna order 12 times. And if you divide the year by 12, you will end up with like every month. So that is kind of the relationship between these two. So if I know how to calculate the Q optimal or EOQ number, then I can use that to calculate the T star, and you just do the math, divide by D, and that makes it equal to 2 times A divided by I times C times D, right? And that is basically how you can get the T value, right? And the next thing is the safety stock. That is in the continuous review, we basically had Z times sigma times square root of LT. This time, because we also have the review interval, we include that into calculation, and we would like to make sure that there is enough basically safety stock to cover us with from this review interval to the end of the lead time next time. And your order up to level becomes to D times LT plus T plus the safety stock. This is very similar to reorder point again. The only difference is in the reorder point, we didn't have this T, but it was just D times LT, right? And overall, our reorder point is D times LT plus T plus the safety stock. Average inventory level calculation as a concept doesn't change. And you do the calculation here, and then the total cost calculation, again, you can use the earlier formula we know, or say that if T equal to Q over D, then Q equal to T times D, and replace all Q's with T times D, and you will get this next formula, which is A over T plus IC TD over 2 plus the safety stock, right? So the only thing you need to basically know is that there is a relationship between T and Q, which is T is equal to Q times D, or Q is equal to T times D, Q equal to T times D, and then you can use the earlier continuous review formulations to calculate the results. How this is done in a example. So let's see this example. Buyer's product company distributes an item known as a tie bar, which is a U-bolt used on truck equipment. The following data have been collected for this item held in inventory. Yearly demand forecast is 1200 units with weekly standard error of forecast of 5 units. Inventory holding rate is 31% per year. Setup cost is 40%. Dollar per order. Item is $25 per unit. Replenishment lead time is 4 weeks. And the customer service level is 95%. Now we are given this information that 1 year is 52 weeks, and we are asked to calculate the optimal review interval, order up to level, average inventory level, and the total cost. Similar to earlier exercises, first we are going to summarize what we know. Demand is 5,200 units per week. E equal to 100 units per week. Standard deviation is 5 units per week. Setup cost is 40. C is 25. Inventory holding rate is 30% per year, which is 0.58. And lead time is 4 weeks. And with a customer service level of 95. So let's go solve this problem. So T star is equal to 2A divided by ICD. I'm going to use weekly information. So what it means is I'm going to use demand per week and the lead time per week. Inventory holding rate per week, which means the end result is going to be weeks as well. I could use 5,200 and 30%. In that case, I would end up with a different number, but and we will discuss that one in class on Monday. Right? Then we could calculate the M value. That is, if you do plug in the numbers, you end up with 656 units. The average inventory level is 138.5 units, and our total cost is $37.10 per week. Right? This is basically how you could do calculate all those numbers. Please do work on this exercise by yourself.